So in this experiment, we're going to be looking at the relationship between the volume of a gas sample and the temperature. So we're going to have a specific volume of our gas sample, which is just air. We're going to warm up that volume of gas, and then we're going to cool down the volume of gas. And we're going to see what happens to the volume when the temperature changes. So volume and temperature, they are directly proportional. So you can expect that the volume for a gas, right, increases as the temperature is increasing. And the opposite is also true. As the temperature decreases, the volume of a gas sample will also decrease. So I have here all the materials that we're going to be using. We have a flask, which is the one that contains our sample. It's just air. It's going to be trapped in there. We have the hot plate with a beaker that it's half full of tap water. So the flask will go here, and we're going to warm up the air inside of the flask. So that's the first things that we have to be doing, setting up the hot plate with the beaker so we can warm up the Erlenmeyer flask containing the air. And then also we're going to be using a rubber stopper with a piece of tubing here. And to determine the total volume that we have of our gas sample, we're using the total volume of this flask here. So I'm pushing my rubber stopper in, and I have a line right there where it's aligning. So I'm going to use this line, right? Whenever we're done with our experiment, we're going to determine the volume with that mark right there. So I will refer to that line later on. So I have my Erlenmeyer flask. It was clean and dry, right? I set up the rubber stopper here. I made the mark on my rubber stopper. So it's clamped, and I'm going to move this Erlenmeyer flask until it goes inside the boiling water. So we're going to keep it there, and what's happening now is that the gas sample is being warmed up. So we're going to keep it there for at least 6 minutes. So a couple of things, like when the flask is inside of the beaker, just make sure that there's no water coming in into the flask, that the flask is not touching the bottom of the beaker or the sides of the container. After the flask has been there for about 4 minutes, we're going to put the thermometer in, and we're going to keep the thermometer there until the 6 minutes has gone by, okay, or whenever it's time to remove the flask from the warm water. Another thing, since the water, right, it's supposed to be boiling when we put the flask in there, you don't need to have this not supposed to be boiling very vigorously, okay? Like you can decrease a little bit the temperature to keep, the water still boiling. And so after the 6 minutes mark, we're good. We can remove the flask. We can determine the temperature because the thermometer it's been there for about 2 minutes. So it should be marking the temperature that you have for the water in the beaker. So we're going to copy the temperature from the thermometer, and that's the temperature for the boiling water. And we're going to use that data point as the temperature of the gas sample that is inside of the flask. Okay? So after that, we're going to remove the flask from the beaker. So now what we have to do is to clamp our piece of rubber tubing here to trap the air, and at this point no more air is allowed to enter or to leave the flask. We're going to remove the flask from the boiling water using the clamp all the way up, all the way up, and very quickly we're going to transfer the flask into my ice water bath right here, and we're going to keep that flask in there for about 4 minutes. under the water and the ice. So the temperature is now decreasing. So you have your gas was warmed up and now it's been cooling down inside of this ice water bath. So after 4 minutes, we're going to remove the clamp from the rubber stopper from the rubbing from the piece of tubing that we have here. And when we do that, water is going to get through the piece of tubing inside of the flask. So you have to make sure that that piece of rubber is under the water at all times. So you can see here the amount of water that went into the flask. So your initial volume of air in here was the entire flask. The entire flask was occupied by the air. Now, after you warm up the gas and now you cool down the gas under the ice water bath, right? Some of that air was pushed out and water got in. So now the volume of your sample it's lower than the initial volume that you had because it was replaced in here by that amount of water. So when the temperature went down, right, when we put this flask under the ice water mixture that I have here, the temperature went down and the volume of your gas sample decreased.